Hello, welcome back to our C Sharp beginner tutorial. In the previous lesson, I think we looked at uh, we let me see where did we? Okay, we moved the show details method from the program class and we moved it to the employee class. Okay, and we also looked at the use of static. So we saw the difference between static variables and dynamic and instance variables. Okay, so today we're going to look at constructor. That's the class constructor. Let me bring up notepad. So spelled like this: constructor, Constructor. Okay, so what's a constructor? Really, a constructor is actually a method. Okay, it is a method. However, it is a special type of method that resides in a class. Okay, so usually when you create your objects, you always call a constructor to initialize the object. Okay, I don't know if that makes sense, but let's go to the code and try to show um, a code we've written before. So in the program.cs class, where we created this employee one equals new employee. This employee that you see here, if you look at it, it looks like a method call, right? But the only difference between this and a method call is that a method call does not usually have a new before it, right? And then also usually because of the naming convention, we don't usually, oh, okay, we do write our methods. We start our methods with capital letters in .NET most of the time, the convention we use. So that's not a big deal. But another thing we should notice is that the name of the method is exactly the same as the name of the class, right? Look at the class. The class is named employee, capital Employee, and the method is also called employee with the same name as the class. Now that is how you know it is a constructor. Okay, a constructor of a class must have, that's the identifier or the name of that constructor must be exactly the same as the name of the class in which um, it resides. Okay. I also said to create an object, we have to call this new and then call this constructor. But if we head back to our employee class, we realize that we did not create any method called employee. That's employee, that's the constructor that we called here. We didn't create one, but it seems like it is available, isn't it? Now, the reason for that is because even if you don't create a constructor for your class, by default, there is always this default constructor that comes with every class. So it looks like this: public void. It's a void. I think you do not. Sorry, for a yeah, that's another difference between a constructor and a method. A constructor does not take a return type. Okay, every method like this show details method must have a return type, which is void in this case. Now the constructor does not have a return type. Okay, so you usually write it like this: public employee, and then you write it exactly as if you're creating a method or you're defining a method. Okay, so this is the default constructor that comes whether you write it or not. This is always available. Okay, so that is why even if we don't write this, we are able to call this new employee and this gets run. Now, what happens when that occurs? When the object is created, nothing is executed because the constructor the constructor, this constructor does not contain any code in it, so it's completely empty. Okay, so what's the use of a constructor? Now, to get really to get full understanding of the use of a constructor, I think I should show you what happens if an object is not properly initialized. So before we go ahead and finish up our explanation of a constructor, let's detour a bit and take a look at what happens if we create an object and then try to use that object without properly initializing that object. Okay, what do I mean by initialization? Let's head back to our program.cs and we'll see. This is what I mean by initialization. So what we've done here from after we've created the employee object, we provide the details for that particular object. That's every single variable of that object, employee one object. We give it a value. Okay, so for first name, this is the value. For middle name, this is the value. It's an empty string. For last name, this is the value. Okay, that is called initialization. I don't know if I've written that before, but let me just bring up Notepad. Sorry, just to show you initialize. Okay, could use S and Americans could use Z. Doesn't matter. So initialization. Okay, that's object initialization. Object initialization. Okay, so the thing with initialization is after you create your object, at the time you create the object, that's after you call this new employee and an object of employee class is created. What happens with these variables, this first name, middle name, last name, ID number, gender? Remember, you have only declared them here. You have not set values for them. Okay, so what happens? In fact, let's go ahead and try something. Let's create at the end of after creating employee 1, employee 2, employee 3, let's create a new employee, employee 4. Employee, we have to declare it first. Employee 4 equals. Also, I want to show you can actually do this. That's you can declare and set the object here on one single line instead of breaking it into 2 lines, just like we do with our int x. Then later we say x equals 5. You can just say int x equals 5. Okay, that's the same thing we're doing here. So we've declared the employee 4, and then we are creating the object of the employee and then setting employee 4 as the object. Okay, so we've done this. We've created a new employee. Now notice what happens if we immediately decide to display the details of employee 4. We have just created employee 4. We haven't set anything. That's we have not initialized employee 4. We have just created the object. So so we go ahead and say employee 4 dot show details. Okay, so we're going to run this program and we'll see what happens. Okay, so we click on play and it ran. I'm pretty surprised that this run. Yes, it did actually run. Okay, I was actually expecting it to trigger a an exception called a null reference exception, but it's surprising it didn't trigger. I think okay, it's mainly the reason it didn't trigger the exception is because all the data types we used for string should be a class. Okay, I'm not sure why it did not trigger that exception. It seems like it initialized everything to empty string, and it ran. Okay, let's try something else. Let me remove this constructor and see if that will make any difference. No, it doesn't. Okay, it still runs successfully. Okay. Um. Okay, this is a bit. This wasn't what I was expecting, really. Um. Let's see. Is there any way I can trigger employee 4 to show details? Uh. Okay. Uh. Okay, just give me a second. Let me just pause this video and then try to think of a way I can trigger that exception. Okay, so I was able to is it accordion? Okay, yeah. Okay, so I was able to trigger the exception, but it's a bit complicated. I don't think we're going to look in anyway. What I actually wanted to show you is there are cases where if you try to create an employee and you do not initialize it, like we've done with these, you go ahead and try to show details. So this is what reference exception looks like. Okay, so during your when you're trying to run your program, it kind of crashes. Okay, so if there was a user using this program, it will crash. That's what happens when an exception is unhandled. Okay, so anyway, I had to go through a lot of well, a bit complex code to trigger it. So I don't think this will be practical to show you, but let's just go ahead and remove. So I created a new class and then made that I'll just remove the code I added. Okay, I'll take out that. Okay. 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 So for now, at least at the moment, it's able to run. Okay, but it's not a good idea to have your objects uninitialized. Okay. At the moment, the reason why this runs actually is because these variables, like the variables in these first name, middle name, last name, ID number, gender, age, and bank name. Even though you did not initialize them, it seems like they are automatically initialized by the C# compiler. I believe it's because they are strings, int, and I think if you have a bool, it will automatically initialize it to true. That's if you don't initialize it. And the the basic data types that you know that we treated, all the basic data types, they get initialized by the C# compiler if you do not initialize them. As you can see in the age, the integer is initialized to 0. The first name is initialized to an empty string. Any string is initialized to an empty string if you do not initialize it. Okay. Now, you will realize that I added a car, a kind of car, like it was a class I created. So after creating that class, it means that for each for that car class, we can create car objects. Okay, and then I added in part of the variables here, I added a car object here. So that's it's actually called composition object, class composition, where you have part of the fields of a particular class is an object of another class. Okay, or a variable that can hold the object of another class. Okay, now it is in those cases where you will run into that unhandled exception. Okay, no reference exception. Okay, so that is why it is always advisable whenever you create a class, it's always a good idea to create a constructor that makes sure all your variables, that's all these variables, are properly initialized. Okay, so for example, that car object or that car variable that I added here, the reason it was giving us the error is because the car object was not initialized here. Okay, so the correct way that would have gotten rid of the error is for us to create a constructor that automatically gets called whenever an object of employee class is created. Okay, so let's go ahead and create our constructor. And like I said, it's like a method, but it does not have a return type, and the name of the constructor has to be the same name as the class. So it's written as public employee. Now, one thing you should know is that a constructor, like I said, is like a method. So it can actually have as many arguments in here as you like. Okay. All right. For now, we'll just start with a basic empty argument constructor. Okay. So and then by default, we're going to set the first name as, we can just set. So basically what we're doing here is just redundant, since as we saw, it actually initializes this. However, if you have an object there, when we start doing class composition, we'll see where this is very, very useful. Okay, so first name, middle name, we set it to empty. What am I typing? Last name, set it to empty. Gender, we can set it to, we can just say male/female, so that will let you know that it has not yet been initialized. And then the ID number, we can say not yet assigned an ID number. Okay, and then finally, the reason I'm writing this as a string, by the way, is because ID number is actually a string. Okay, so if, for example, age here, we cannot write a string. So in fact, let's go ahead and set the age. We can set it as since it's not yet set, we can set the age. So let's set the default age to be 25. Okay, so this means that if an employee is created, whenever an employee object is created by this constructor, the first name is going to be empty by default. That's by default. The middle name will be empty, the last name will be empty, the gender will be male/female. Okay, and then the ID number will be this string, not yet assigned an ID number, and then the age by default is going to be 25 unless you later change it. Okay, so let's go back to our program.cs, and you can see now employee, we have employee 4.show details. We created the employee 4, and we did not initialize it as we did these 3. So notice what's happening here. For this employee 1, after we create the object, remember, by default, when we call this constructor, this is the constructor that gets called. Okay, after the object is created, all these, first name is set to empty, middle name is set to empty, last name to empty, gender is set to this, ID number is set to this, age is set to this. But then immediately after that, we begin to change. You notice we begin to change those details for employee 1. So you see, employee 1 first name is now changed to Abdul. Okay, by running this this line of code, it gets that empty first name string is changed to Abdul. Okay, it kind of gets overwritten. Okay, Same thing goes for employee too. After setting the default settings, that's these are the defaults, it immediately gets changed to these. Okay, and then for employee 3, same goes that. But for employee 4, notice what happens. We did not change immediately after we call the default, that's the default constructor. We tell it to show the details of employee 4, and then go ahead to show the details of employee 1, show the details of employee 2 and employee 3. So the first detail we're going to see is the details of employee 4. Okay, so let's go ahead and save. Let's choose save all and then run this program and see what happens. Okay, I don't like that. Let's just go ahead and add that space, console.writeLine, so that we separate console.writeLine, so that we separate the details of employee 4 and details of employee 1. So let's go ahead and run again. Okay, good. So you can see the first details are the details of employee 4. You see, even though we did not, when we created the object here, this is where we created the object, we did not set these values. However, because by the default template in the class, the default constructor sets those details to these. Okay, so the name is empty. Remember, the name is a combination of first name, middle name, and last name. The ID number is not yet assigned an ID number, just like we wrote it there. The gender is this, the age is this, the bank is obviously GT Bank, because that's a static variable which we use. Remember the static variable we did in the previous class. So notice for the for employee 1 to employee 3, notice that all those details, that's these default details, get overwritten, and the correct details that we set later are the ones that are showing. Okay, so that's the use of a constructor. Okay, the main use of a constructor, even though we didn't really get to see the use per se here, the reason was because of what I explained earlier, because the basic data types, string, boolean, integers, they get initialized automatically by the compiler even if you don't initialize it. So that's why you are able to run. We didn't really get to see the work of a constructor, but by the time we start doing class compositions and we're having an object, like for example, say we have a car class, okay, and a car class can create car objects, and then in under our employee class, we want every employee to be able to have at least a car object. In that case, you realize that that car object needs to be initialized. Okay, that car object needs to be initialized before an employee becomes like a valid employee object. I don't know if that makes sense, but anyway, maybe later we're going to see the real use of constructors and why they are important. Okay, just before we end the class, I would like to show you that you can actually overload constructors. Okay, let's just bring up notepad and write it down. Constructor overloading. Okay, constructor overloading. Overloading is actually it's not just on constructors. In fact, every method, okay, every method can be overloaded. Okay, you can overload methods. What else can you overload apart from methods? Okay, maybe we'll come across other things you can overload later, but for now just know that you can overload methods and you can overload constructors. Okay, what does that mean, overloading? Overloading means having one item, okay, or having more than one item, having more than one item or entity with the same name, okay, or with the same identifier. You remember what an identifier is? For example, a class, this is the identifier of this class, okay? The employee class, this is the identifier of this of the employee class. This is the identifier of the first name, this variable, okay? This is the identifier of the middle name variable. This is the identifier of the last name variable, okay? So that's what an identifier is. Let's go back to our notepad and read it again. Having more than one item or entity with the same identifier means you are overloading that particular entity, okay? Now let's practically have a look at how you overload constructors. So for example, this is a constructor, isn't it? This is its identifier, this employee, employee. Now if you have another constructor with the same name with this, that constructor becomes the constructor for this class becomes overloaded, okay? It means there are more than one constructor, and which one gets called, that will depend on the one you call, okay? Let's go ahead and create the second constructor, public employee. But notice that you cannot, even though they have the same name, you cannot have them to be exactly the same. That's have exactly the same signature. I don't know if that makes sense. The same signature means having the same identifier and also having the same types of arguments and also having the same return type. Now, since constructors do not have return types, so we don't care about the return type. However, what we care about is the identifier and the arguments. Notice that there are no arguments for this constructor. Also, there are no arguments for this constructor, okay? Then the name of the constructor, obviously the name of the constructor must be the same name as the class. So the name of the constructor must be the same name as the class. Now this means that the two have the same signature, okay? Let me just bring up notepad. I think these are very, very important things you should take note of, because in most of the books you're going to read, they'll be talking about signatures, overloading, method overloading, constructor overloading. So it's good to know them. So signature written like this, okay? Signature of a method. You can say signature of a method or signature of a constructor. Now the signature of a method or signature of a constructor is a combination of the return type. Remember we said constructors don't have return types, so that's we don't care about the return types for constructors, but for methods we do care about the return types, okay? It's a combination of the return type, okay? That's one. Let's list them out. There are actually three main things that make up a signature. Combination of return type, the arguments and their data types and their types, okay? That's the data type of the arguments and their configuration. The arguments and their types, the arguments and let's say the arguments, their types and their order. I don't know if that will make any sense, but the order, what I mean by the order is the way they are arranged in the way they are arranged within the normal brackets, okay? So if an integer comes first, then say a boolean comes second, and then in this constructor, and a boolean comes first and then an integer comes second, you realize that they are no longer the same signature. Okay, even though this has an integer and a boolean as arguments, this also has a boolean and an integer as arguments. But because the order in which they are passed, the integer comes before the boolean here, and the boolean comes before the integer here, so that makes them different signatures. Okay, they have to have exactly the same order in which the arguments are passed. I hope that makes sense. And then finally, after combination of the return type, the arguments, their types, and their order, and what else? I think that's it. That okay, the identifier. Yeah, the identifier. So I said the identifier is this particular name that you give. So those are the three things that make up the signature of a method or a constructor. Okay, these three items are what make up a signature. This is actually very, very important. So maybe you should take time and make sure you understand that. Okay, because you will later on in the later lectures, we're going to talk about signatures, overriding, overloading, and other techniques in programming. Okay, so it's very good you get a very good grasp of what a signature is. Okay, all right, let's head back. So I just explained what signature is. Now, because these two have exactly the same signature, you cannot have, this is not overloading. Okay, this is not overloading. Now for you to overload a method, you have to they have to at least have different signatures. So the signature of one of them has to be different from the signature of the other one. Okay, it's basically it's not just two methods or two constructors. You can have as many constructors as you like. Okay, but each constructor must have a unique signature different from the other one. Okay, so all I'm trying to explain here is, in this case, here we can actually do something like string first name, or let's not confuse, let's just put f name, put a comma. So I'm separating. Notice immediately I add this string f name, this red line disappears because it realizes that this constructor has a different signature from this constructor. So even though they have the same identifier, which is what is actually needed if you want to overload a constructor. Okay, even though they have the same identifier, their signature is different. Okay, so it immediately recognizes, since they have different signatures, it understands that we are trying to overload this employee constructor. Okay, so let's finish up the second constructor, middle name, let's call it m name, and then oh sorry, we have to signify the data type, string m name, and then string, we'll call it l name for short, and string id, is that, yeah, id number. I'll show you where we're heading with these arguments, and then string gender. Okay, and then int age, and then find, oh okay, we don't need that's a static variable, so we don't need that. Okay, so you realize that by doing this, our code is now correct. We have successfully overloaded this constructor. Okay, and then in here, we can go ahead now. This, when we call this constructor, notice that the constructor expects you to pass a first name or a string, which will be taken as the first as f name. It expects you to pass another string next after that, which is going to be taken as this local variable m name, and then the L name, the ID number, the gender, the age. Notice the order in which we set these arguments. The order has to match the order which you are going to call the constructor. Okay, let's just go ahead and finish up the code. Maybe it will make more sense when you see it in action. Okay, so here we're going to set the first name to be equal to f name. Okay, so notice this first name is the first name. Remember, it's an instance variable, okay, which belongs to the object, whichever object it's being operated upon. Okay, I don't know if that makes any sense to you. Okay, but I'm just trying to do my best to explain well, let me see if there's a better way to. Okay, let's just finish the code. I think it will make more sense when we finish it. So we'll go ahead with middle name equals m name, and last name equals L name, ID number. So we're just setting the instance variables to the values which we pass within this constructor. Okay, ID number equals, okay, I don't like that we name this ID number same with this. I want them to be different names, so we'll just call this ID num. So equals ID num, and then also I don't like gender and age because we're naming them the same name as this. I don't like that. For the age, I'll just put age. Okay. By the way, this is very bad naming convention. Please do not. I'm just doing this so that you get, okay, maybe I should actually do it the correct way I would have done it if I was writing my code. Okay, so if I was writing my own code, I will actually write it as first name. Now the reason, okay, I remember why I didn't want to do that. I don't want to do that now because I don't want to confuse you. I don't want to introduce this keyword. There's a keyword known as this, like this, THIS. This is a keyword. I don't want to introduce it yet. So for that reason, for now, just bear with me. We're going to rectify, or I'm going to explain how you should be naming your variables. Just know that this is not a good naming convention. Okay. For understanding purposes, we're just going to use them for now. Okay. So gender. So I want you to know that this gender, this variable, is different from this GEND. Okay, there are two different variables. This is a local variable which takes the value of whatever is passed, and this is the field of instance variable of whatever object is being worked upon. Okay, and then finally age equals age. Okay. Okay, that's it for this constructor. So notice that the two constructors do different things. If you, after creating your object, you call this constructor to initialize your object, the object you just created, the default values are going to be these. Okay, but if you call this particular constructor at the time after you create your object, the default values are going to be whatever values you pass in as argument at the time you call the constructor. Okay, now to show this, I'll just head back. Okay, let's just save this file, save all, and go back to program.cs, and we'll see an example of using. Already we've used this constructor with the employee 4. We're going to create a 5th employee, and we're going to use this constructor to initialize that employee. So let's go back to program.cs. This is where we created our employee 4, and we displayed the details of employee 4. We're going to create a new employee. We're going to say declare it first, employee 5, and then double E 5, and then equals. And by the way, I just want you to know that me calling them employee 1, employee 2, employee 3, it's just my choice. Okay, there's nothing stopping you from naming this whatever you want. You can call it Kyle. Okay, so now KYLE becomes a variable that holds an object of employee. Okay, you can call it that new employee. Okay, you can call it whatever you want, so there's nothing stopping you from giving. Just know that whatever name you give it here is going to be the name you're going to be using whenever you want to access that particular object. Okay, so this is just an identifier. Okay, all right, let's just go ahead and change it back to our employee 5. Employee 5 equals new employee. Now notice what happens if I open this bracket. Do you see this triangles? There's one going up, one going down, and it's showing you one of 2, and then beside it is writing employee, and then a normal open bracket and a normal closing bracket. This, whenever you see these arrows, it and shows you one of 2 or one of 3 or one of 5 or one of 6. If you see one of 2, it means there are actually 2 overloads for this particular method or constructor. In this case, since employee is a constructor, for this particular constructor there are 2 overloads. Okay, and this is the first one. The first overload is this this particular one that takes no argument. Okay, and then if you click on this, the one pointing downwards or the one pointing upwards, doesn't matter, anyone. If you click on it, it's going to show you the second overload. Okay, that's the second one, and notice what happens. It is expecting a string. I like the way Visual Studio actually this IntelliSense tells you, it like gives you information on the things you need to pass in. Okay, it tells you that you need to pass an argument of string data type as a f name, another argument string middle name or m name, another argument string l name, then another argument string id number, id num, and then another argument string gen, and another argument int ag. Now you see why I was telling you that this is not a good naming convention. Imagine if we have had where we had written that's where we created this employee constructor overload, and we used first name, middle name, last name, id number, gender, age. You notice that immediately you see it here, you know, even if you're not the one that wrote the employee constructor, you will know that, oh yes, I'm supposed to pass the first name here, I'm supposed to pass a middle name, whereas here it's not so clear what you're supposed to pass. Okay, so that was why I was telling you this is not good naming conventions, but there was a reason why I wanted to do it this way. Like I told you, I wanted you to know that there are 2 different variables, the gen variable and that gender variable, gender field. Okay, so let's go ahead and finish up employee 5 using this second overload. Okay, so we're going to pass a string as the first name, so we're going to call him let's say Sani, and then after every argument you use a comma. Okay, and notice immediately I put the comma, look at this M name is now written in bold. Remember, before I entered the comma, this F name was written in bold, telling you that that's the one you're supposed to write. Now, this one is written in bold, telling me that it is the M name I need to write in now. Okay, so I'll go in and write the middle name, let's say O, and a dot, and then after the closing quotes, I put a comma, and then it's telling me L name, so I should put the last name, let's say Jonah, and then a comma. The ID number we could set 24357. Okay, a comma, and then gen, which is the gender, so we'll just say male, and then a comma, and then the age, so we can just pass in. Remember, the age is a number. 65 is probably too high. Let's say 43. Okay, and semicolon. Okay, all right. So notice the semicolon is to end the statement. Okay, every statement needs to end with a semicolon. All right. We're going to run this program. Let's go to File, Save All. I've already clicked on Control S to save it, but I just saved again. So let's run this program and see what happens. Okay, we forgot to show the details of employee 5. So let's go ahead and say employee 5 dot show details, and then console dot write line to separate. I'll just choose this. Okay, to separate the employee 5 details from employee 1 details. So employee 4 details is going to be displayed first, then followed by employee 5 details, then employee 1, employee 2, employee 3. Okay, and then the main thing I want us to focus on is these constructors, this one and this one. Notice how we call this constructor to initialize our employee 4, and notice how we called this constructor to initialize our employee 5. Okay, we use this overload to initialize employee 4, and we use this overload to initialize employee 5, which means we expect employee 4 to have those default details. And look at how convenient it is to use this as opposed to writing this. Anyway, let's just run this program and see what happens. So I've clicked on run. Okay, I've scrolled to the top, so we see, let's enlarge this to see the full. Okay, so this is employee 4. As you can see, it was employee 4 details that was output first. So you can see it's the default details, and then notice employee 5, right? That's employee 5 details. Notice employee 1, employee 2, employee 3. Now I want to ask you a question. Which one looks neater? Compare the way we initialized employee 5 and the way we initialized employee 3, and the way we initialize employee 2, and the way we initialize employee 1. Which one looks neater? Notice how many lines of code we used to initialize employee 3 only. 1, 2, 3, 4, 5, 6, 7, 8. Okay, ideally we can actually take this to be one line, since we kind of cheated and just use this immediately. Sorry, this one. We declared and initialized at the same time. So let's count this as 1. 1, 2, 3, 4, 5, 6, 7. 7 lines of code to initialize employee 3. Now notice what happens with this employee 5 using the overloaded constructor. We use only a single line of code. Now, how convenient is that? Notice it might not look so efficient, or well, it does look efficient, but you would be thinking, oh, okay, what's the difference between 7 lines of code and 1 line of code? Now imagine if you were creating 100 employees, right? By the time you multiply 7, or let's say the difference, 7 minus 1, 6, 6 multiplied by 100, that's 600 extra lines of code in which you could have achieved the same thing. Okay, you have 600 extra lines of code. That's if it is 100. If it is 1000, you're talking about 6000 extra lines of code. Okay, so you can see how constructors make your code very compact and very efficient, and they also save you from the problem I showed you earlier at the beginning of the class, the running into no reference exception. Okay, we're going to see that later, like I explained to you. Okay, so I think we should go ahead and end this class, but before I do that, I just want you to make sure you understand something here, telling you that's saying you it's not just two overloads. We can actually have a third overload. You can have as many overloads as you want. So employee, as long as they have different signatures or unique signatures. So we can say string X. This is very bad. I'm just being I'm just trying to write short. Okay, it's very bad naming convention. Please don't use this as variable names. Okay, so by doing this, this is another constructor. Okay, so you can have as many as long as they have different signatures. Okay, you can have as many constructors as you want. All right, that's the end. That's going to be the end of this class. I think we've at least covered something. So in this class, we were able to see what happens when an object is not properly initialized. Okay, on a null reference exception on some cases. Okay, and we also saw the class constructor. We saw the use of a constructor. We saw the importance of constructors. Okay, and we also saw how we can overload constructors. Okay, finally, I think we saw how useful a constructor can be in compressing our code. Instead of writing 7 lines of code to initialize an employee object, we achieve that by writing just 1 line of code. Okay, all right, this is going to be the end of this class. See you in the next class.